This is why we'll never reach the edge of the solar system. Imagine this. Humanity's greatest explorers, the Voyager spacecraft, have been racing away from Earth for nearly half a century. They carry with them the sounds of our planet, the music of Beethoven, greetings in dozens of languages, and a golden record that serves as a cosmic message in a bottle. They are moving faster than any human-made object in history. And yet, despite all that speed, despite traveling billions upon billions of kilometers, Voyager has not even come close to leaving the solar system behind. The truth is, the solar system is not what we think it is. It doesn't end at Pluto. It doesn't end where the last planet orbits. In fact, it stretches so far into the darkness that even after thousands of years, Voyager will still be trapped inside. This is the mystery no one tells you. Escaping the solar system may be the hardest journey humanity will ever face. When most people hear the words solar system, they picture the sun, the planets, maybe a few moons and asteroids, and then some empty blackness beyond Pluto. But the reality is much stranger and much larger. The solar system is surrounded by an invisible, spherical cloud of icy bodies, stretching almost halfway to the nearest star. This is called the Oort Cloud. And if you want to leave the solar system, truly leave it, you have to cross that unimaginable boundary. Let's put this into perspective. Voyager 1, launched in 1977, has been traveling at over 60,000 kilometers per hour for nearly 50 years. It is now more than 24 billion kilometers away from Earth. That's so far that signals take over 22 hours to reach it. And yet, compared to the Oort Cloud, Voyager has barely moved. To exit the solar system completely, it would need around 14,000 years. 14,000 years! That's longer than all of recorded human civilization, from the first cities in Mesopotamia to the present day. Think about that. Every empire, every war, every invention we've ever created, all of it, could pass again and again, and Voyager would still not be free of the sun's influence. And this raises a haunting question. If even our fastest spacecraft are still trapped, how could humanity ever hope to leave? The first thing to understand is that the solar system has no clear edge. There's no wall you can cross, no line that says you are now outside. Instead, the sun's gravity stretches endlessly into space, pulling on every comet, every dust grain, every speck of matter. What scientists call the edge is really the point where the sun's influence fades into the background of the galaxy, where the solar wind collides with interstellar space. Voyager 1 crossed that region in 2012. But here's the twist. Even though we say Voyager has entered interstellar space, it hasn't escaped the solar system. It's still under the sun's gravitational grip, and it will be for thousands of years to come. Picture it like this. Imagine the sun's gravity as an invisible ocean. All the planets and comets are floating in it, and even if you swim outward, you're still in the water. The Oort Cloud is the outer shoreline of this cosmic ocean, and beyond it lies the true open galaxy. Voyager is still paddling near the coast, but the scale of the Oort Cloud is something that almost defies human imagination. Scientists believe it stretches from about 2,000 astronomical units away. That's 2,000 times the distance from the Earth to the Sun, all the way out to perhaps 100,000 astronomical units. At that distance, the Sun would appear no brighter than any other star in the night sky, and yet, even there, its gravity still tugs on icy worlds. Think about what this means for exploration. Even if we built a spacecraft 10 times faster than Voyager, it would still take more than 1,000 years just to leave the Oort Cloud behind. Now, let's rewind to the Voyagers themselves, because they show us both the possibility and the limitation of human exploration. Launched during the Cold War, designed originally just to tour the giant planets, these spacecraft have far outlived their creators' expectations. Voyager 2, for example, gave us our first close-up look at Uranus and Neptune. It revealed storms the size of Earth swirling in Neptune's atmosphere. It discovered active geysers erupting from Triton, Neptune's frozen moon. These were discoveries that changed planetary science forever. And yet after that, Voyager kept going, carrying its tiny nuclear battery, whispering data back across the abyss. Voyager 1, meanwhile, raced even faster, becoming the most distant human-made object. In 1990, it turned its camera back toward Earth and captured the pale blue dot, the most famous photograph in history. our planet suspended like a mote of dust in a sunbeam. Carl Sagan reflected on that image, reminding us that all of human history, all our triumphs and tragedies, are contained on that tiny speck. That photo alone may be Voyager's greatest gift to humanity. But in a way, the pale blue dot also emphasizes why the edge of the solar system is unreachable. Because even Voyager, after traveling so far, still looks back and sees Earth as home. It hasn't escaped. Not truly. It is still a child of the sun, bound to its gravity, moving ever outward but never beyond. And this is not just philosophy. The physics of interstellar travel make it brutally clear. To escape the sun completely, a spacecraft must reach a velocity beyond what we can currently achieve with chemical rockets. The sun's gravitational well is deep, and its reach is immense. Every kilometer per second of velocity requires staggering amounts of energy. Even with nuclear propulsion, ion drives, or futuristic ideas like solar sails, the time frames are daunting. We are not talking decades or centuries, we are talking millennia. So why do scientists care about this? Why does it matter that the edge of the solar system is so far away? Because it changes how we think about exploration and about ourselves. It means that the solar system is not a local neighborhood but an empire spanning light years. It means that we are, in a very real sense, still trapped in the sun's domain. And it means that if we want to reach other stars, we will need technologies that go far beyond anything we've ever imagined. Some scientists dream of fusion drives, spacecraft that could reach perhaps 10% of the speed of light. Others talk about laser-powered light sails, riding beams across the void. Projects like Breakthrough Starshot aim to send tiny probes to Alpha Centauri within a century. But, compared to the Oort Cloud, even these ambitions feel fragile. To reach the true edge of the solar system, to escape the sun once and for all, remains a challenge beyond our lifetime. And yet this is also what makes the idea so powerful. Because it forces us to think in terms of civilizations, not individuals. What if humanity does survive for thousands of years? What if our descendants, living on colonies around Jupiter or orbiting Saturn's rings, send ships that push ever outward, generation after generation? What if the edge of the solar system becomes not a destination, but a journey that defines who we are? This is why Voyager matters. Not because it will escape in our lifetimes, but because it shows us the scale of the challenge. It is a messenger from the present to the deep future. A reminder that exploration is not about instant gratification, but about persistence across the ages. Voyager carries the golden record not for us, but for whoever may find it in 10,000 years. That is the time scale we are dealing with when we talk about leaving the solar system. So when we ask why we'll never reach the edge, the answer is not defeat. The answer is perspective. On human timescales, the edge is unreachable. On cosmic timescales, it is inevitable. But let's go even deeper. Because when we say the edge of the solar system, we're still simplifying. The truth is, space doesn't give us clean boundaries. It gives us layers, invisible zones that stretch farther and farther into darkness. The first of these zones is the heliopause, where Voyager 1 currently drifts. That's the point where the solar wind, the constant stream of charged particles from the sun, meets the pressure of interstellar space. Scientists celebrated when Voyager crossed this frontier in 2012. For the first time, a human-made object had left the sun's protective bubble and entered the raw, untouched medium between the stars. But gravity doesn't end there. The solar system doesn't end there. Because beyond the heliopause lies the Oort Cloud, and here is where the story becomes almost mythological. The Oort Cloud is a shell of icy fragments, leftovers from the birth of the solar system. Billions, perhaps trillions of frozen worlds, scattered like ghosts, orbiting at distances so vast that a single orbit can take millions of years. These are the seeds of comets. When one of them is nudged by the pull of a passing star, it can fall inward, becoming the fiery comet you see streaking across the night sky. Every comet we've ever witnessed is a messenger from this hidden realm, a traveler from the edge of everything, and yet, no spacecraft has ever come close to it. No telescope has ever seen it directly. The Oort Cloud is invisible to us, inferred only by the behavior of comets. It is a frontier that exists more in theory than in sight. But if it is real, and most scientists believe it is, it defines the true extent of the solar system. Let's pause here. Think about what this means. Voyager 1, after nearly 50 years of flight, has traveled 24 billion kilometers. The inner edge of the Oort Cloud may begin at 300 billion kilometers, and the outer edge, perhaps 7.5 trillion kilometers away. That's not just far, it's almost incomprehensible. If the Earth were the size of a marble, the outer Oort Cloud would be kilometers away. Voyager hasn't even traveled a centimeter, so when we say we'll never reach the edge of the solar system, it isn't clickbait, it's not exaggeration, it's the reality of scale. We are creatures of decades. The solar system is built for eons. But here's the paradox. The Oort Cloud doesn't just trap us, it protects us. It is a shield against the galaxy, a reservoir of comets that might one day deliver water and organic material to young planets, just as they once did to Earth. Without the Oort Cloud, without this vast halo of icy remnants, our planet might never have become habitable. In a strange way, the same structure that makes escape impossible is also the structure that gave us life. And this leads to a haunting realization. Maybe the solar system was never meant to be left. Maybe it was meant to contain us, to nurture us, to challenge us. When Carl Sagan called Earth a pale blue dot, he wasn't just talking about our planet. He was talking about our place in the cosmos. The solar system itself is a cradle, and like all cradles, it is both shelter and prison. But humans are restless. We dream of other stars. We imagine ships sailing to Proxima Centauri, colonies orbiting distant suns, new Earths waiting for us across the galaxy. So the question becomes, can we ever escape? The physics says no, not with our current technology. Chemical rockets, nuclear batteries, even ion engines, they can't cut it. But physics also gives us hope, because there are concepts, still on the edge of possibility, that could rewrite the story. Take fusion propulsion. If we could harness the same reactions that power the sun, we could build engines capable of reaching 10% of the speed of light. At that speed, the Oort Cloud would shrink from millennia to mere centuries. Or consider solar sails, sheets of reflective material pushed by the pressure of sunlight or lasers. Theoretically, they could accelerate continuously, reaching incredible speeds without fuel. Projects like Breakthrough Starshot dream of sending gram-sized probes to Alpha Centauri in just a few decades, riding beams of light. If such technology were scaled up, humanity might one day ride the same principle to the edge of the solar system and beyond. And then, there are the wild ideas, the Alcubierre warp drive, bending space itself to move faster than light, wormholes, shortcuts through space-time. These remain in the realm of theory, requiring negative energy or exotic matter. But who is to say what thousands of years of science might uncover? Voyager itself would have seemed like science fiction to people living in the Middle Ages. Still, here is the sobering truth. Even if we unlock these technologies, the solar system's scale will humble us. Escape will never be easy. It will always be measured in lifetimes, not years. And this forces us to think differently about exploration. Instead of imagining a single ship, a single mission, we must imagine continuity. Generation ships, where entire societies live and die en route to the stars. Robotic emissaries, spreading like seeds across the galaxy, carrying the knowledge of Earth long after we are gone. And here is the ultimate irony. In trying to leave the solar system, we may end up appreciating it more, because it is ours. Because it is vast enough to hold humanity for millions of years. Because it connects us to the galaxy without letting us slip away. The solar system is not just where we live, it is who we are. So the next time someone asks why we'll never reach the edge, remember this. The edge is not a place. It is an idea. It is the reminder that the universe is bigger than us, that our journey is longer than our lives, and that exploration is not about reaching a destination, but about daring to move at all. Voyager will keep flying, silent and patient. Long after its batteries die, long after Earth has changed beyond recognition, it will drift toward that unreachable edge. Maybe one day, in 10,000 years, another civilization, perhaps our descendants, perhaps strangers, will catch up to it, read the golden record, and remember who we were. Or maybe it will continue alone, a lonely ambassador, a story without an audience. But either way, it carries the truth. That we tried. That we reached for the stars, even if we never grasped them. And maybe, just maybe, that is enough. Because in the end, the edge of the solar system isn't something to conquer. It's something to wonder at. A boundary that reminds us how small we are and how infinite the universe remains. This is why we'll never reach the edge of the solar system. Not because we aren't capable, not because we aren't brave, but because the cosmos itself has written the rules of distance and time. And that's the mystery. The more we search for an end, the more infinite it all becomes.